Hello everyone, my name is Kushal Reddy K from Venkateswara College of Engineering and my today's topic is about impact of agricultural areas using cloud computing. So in this topic we are going to discuss about abstract, introduction, cloud computing techniques, agricultural model based on cloud and cloud services. Cloud computing is a network-based environment that focuses on sharing computations, storage, service, applications and other important computing resources. In modern era of cloud computing technology, very helpful for centralized all agricultural related data bank, that is soil related, weather, research, crop, farmers, agricultural marketing, fertilizers and pesticide information in the cloud. Latest technological development has through a dramatic change in every field of agriculture, and cloud is no exception to it. Cloud computing technology impacted positively on agricultural field and related services they provide for users. This topic also discuss cloud computing model, its characteristics, its deployment model, the services that cloud provide, and the benefits and challenges of the cloud in agricultural field. So coming on to the introduction of cloud computing, what is cloud computing? Cloud computing is defined as storing and accessing of data and computing services over the internet. It doesn't store any data on your personal computer. It is the on-demand availability of computing services like servers, data storage, networking, database, etc. Some of the examples of cloud computing are AWS, that is Amazon Web Services, Google Cloud and Azure. Cloud computing has evolved as a key computing paradigm, allowing for simple on-demand access to a shared pool of configurable computing resources through the internet. An increasing development of IT and communications and growth of data, emergence of new applications and computing needs, capacity and implements is exponentially day by day. Cloud computing is a new approach which brings the information computing and storage from PCs into giant data center. In these information needs as services via internet. On the other hand, the third person needs to do this on computational requirements, services, efficiency, storage capacity, and increasing the reliability on agricultural area. Cloud computing applications in agriculture is in place of theoretical research and lack of mature cases. This technology is great significant to improve agricultural field construction, the combination of agricultural information and modernization. So here we learn about cloud computing technologies. Nowadays, witnessing a steady trend in the loss of agricultural land and biodiversity worldwide, adding to this adverse weather conditions induced by climatic change and an increase in world population struggling for scarce resources are projecting a grim picture of the future. It may be able to alter or even reverse this trend using technologies already in place. Cloud computing may prove to be a formidable asset. There are practical applications for the use of cloud computing that create a whole ecosystem from sensors and monitoring tools that collect soil data to agricultural field images and observations from human actors on the ground accurately feeding data repositories along with their GPS coordinates. So coming to this diagram, the structure, we learn about the structure of cloud computing based agricultural system. Here, as we see, we have three layers: software as service, infrastructure as service, and the end user. In software as service, it means that the end user will deal with the site remotely over the internet. There is CRM, customer relationship management, and the data center, which displayed by Amazon Web Services, are example for this model. And coming on to the infrastructure as service, it gives developers the permission to take the highest level of direct interaction with the infrastructure of servers. It also allows them to deploy their own applications in remote environment and to control them remotely. So far, the software as service model is the dominant model in the current industry. And coming on to the platform as service, the best example of platform as service is the Google App Store. It is primarily aimed to at the developers' activities who want to deploy the applications directly in the cloud server and they haven't any interest in the connection of infrastructure of the servers. An open and cloud-based system that captures and shares data from many types of precision agricultural controllers on a farm to lower costs and reduce environmental impact. Additionally, cloud technologies have launched for food and agricultural industries and are utilizing information communications technology to ensure plentiful food supplies in the future. Cloud computing in agriculture continues to increase, so too will the number of questions about it. To answer the most frequently asked questions, I've identified the top 5 things you need to know before entering the cloud according to IT experts. The first question is about private or public. A private cloud built using resources in your data center leaves you in control but also means you shoulder the management overhead. Public cloud services relieve you of this in management burden but at the expense of some control. Is security a concern? For a long time, people were concerned about the security of cloud computing platforms, but most of them are actually now much more secure than traditional approaches that they replace according to experts. What are the benefits? Many cloud computing services provide claim that they significantly reduce the cost and complexity of owning and operating computers and networks. Cloud services can often be customized and flexible to use, and providers can offer advanced services that an individual company might not have the money or expertise to develop. How can I ensure success? According to an April 2011 online survey by Baseline, two critical elements of a cloud strategy are not commonly recognized: attention to service levels and focus on integration. Also, IT leaders should obtain hands-on experience with cloud computing to learn its capabilities before implementing a company-wide solution. Will the role of my IT department change? Cloud computing will not eliminate the need for an IT team, but many experts believe it will likely shift the role it plays within an organization. Before cloud computing technical support spent much of its time monitoring and recovering all devices and systems to make sure they were available for business operations. So coming on to the agricultural model of the cloud, farmers can also use the cloud to access the information from predictive analysis institutes, whereby they can have an accurate prediction on products that are in demand by different markets and adjust production accordingly. There is also an incentive for farmers to use knowledge-based repositories containing a wealth of information related to farming practices, crops input, agricultural innovations, pesticides, seeds, fertilizers, nutrients, and weed resistance, as well as on equipment. All this comes along with expert advice from a wide range of sources. For example, on farming and processing of agricultural products, this scenario can also be extended to include access to consumer databases, supply chains, and billing systems. So here in the diagram, we learn about cloud computing applications in the agriculture, high integration and sharing of agricultural information, where the farmers can share the information related to the agriculture to each other, and real-time monitoring and guidance in agricultural production. They can monitor all the real-time data and take the necessary actions required, providing agricultural science and technology services. The farmers can share their knowledge among each other and thus improving their own efficiency. Construction and improvement of the agricultural products supply chain, tracking and monitoring of agricultural products quality. For many farmers and those in agricultural sector, much of their livelihood involves giving up control to the force of nature. But what if farmers could take back control with the help of technology? Cloud computing can be used to aggregate data from tools like soil sensors, satellite images, and weather stations to help farmers make better decisions about managing their crops. The cloud's analytic capabilities also aid farmers in understanding their production environment. Meanwhile, farmers themselves are getting hands-on with the cloud. Farmers can then visualize their fields on the map and pinpoint exact areas that need more fertilizer or water. By providing decision, support, and automation, these cloud-based solutions help solve agricultural problems and increase the efficiency and productivity of farms. Farmers can also use the cloud to access information from predictive analysis institutes, whereby they can have an accurate prediction on products that are in demand by different markets and adjust production accordingly. All this comes along with expert advice from a wide range of sources, for example, on farming and processing of agricultural products. This scenario can also be extended to include access to consumer database, supply chains, and billing systems. The current limitation for the adaptation of cloud computing services is rural internet speeds. Imagine having gigabytes of image data that takes hours, if not days, to get uploaded to the cloud due to slow internet speeds. This slow round trip time and to and from the cloud can delay decision time. data privacy and security remains the biggest concern with cloud computing services for agriculture. Computing requires detailed information about farm conditions and operations to travel outside parties, including the cloud provider and third parties that help analyze the data. This can raise both privacy and security concerns for farmers as they worry about who may gain access to information that reveals their farming strategies, their yield, their land, and their business operations. The current limitation for adoption of cloud computing services is rural internet speeds. Imagine having gigabytes of data that takes hours if not days to get uploaded to the cloud due to slow internet speed. This slow round trip time to and from the cloud can delay decision making. Data privacy and security remains the biggest concern with cloud computing services for agriculture. Here in this diagram we study about cloud based precision farming management system based on plant protection expert knowledge. Here firstly we take data analysis via plant protection software, and then you have the exchange with external bodies where mobile and device terminal are connected to the decision for farming operations, and then we keep a record of the information from PF service companies and data from agronomic sensors and data from machinery and accessory devices. The weather data is stored, and all these data together accessed as data collection. And this is how the cloud-based precision farming management system based on plant protection expert knowledge works. Even though cloud computing has been very beneficial in agricultural sector, they face some challenges like deficient production information, not enough sales and distribution information, poor knowledge about the weather forecast, pests and diseases, poor ICT infrastructure and ICT illiteracy, lack of awareness among farmers about the benefits of ICT in agriculture, insufficient powers availability in rural areas, and data security and privacy. Data security is a major concern when working with cloud environments. It is one of the major challenges in cloud computing as users have to take accountability for the data, and not all cloud providers can assure 100% data privacy. Lack of visibility and control tools, no identity, access management, data misuse, and cloud misconfiguration are common causes behind cloud privacy leaks. There are also concerns with insecure APIs, malicious insiders, and oversights or neglecting cloud data management. Multi-cloud environments. Common cloud computing issues and challenges with multi-cloud environments are configuration errors, lack of security patches, data governance, and no granularity. It is difficult to track the security requirements of multi-clouds and apply data management policies across various ports. Performance challenges. The performance of cloud computing solutions depend on the vendors who offer these services to clients, and if a cloud vendor goes down, the business gets affected too. This is one of the major challenges associated with cloud computing. Interoperability and flexibility. Interoperability is a challenge when you try to move applications between two or more multiple cloud ecosystems. It is one of the challenges faced in cloud computing. Some common issues faced are rebuilding application stacks to match the target cloud environment specifications, handling data encryption during migration, settling up networks in the target cloud for operations. High dependence on network. Lack of sufficient internet bandwidth is a common problem when transferring large volumes of information to and from cloud data servers. It is one of the various challenges in cloud computing. Data is highly vulnerable and there is a risk of sudden outages. Enterprises that want to lower hardware costs without sacrificing performance need to ensure there is high bandwidth, which will help prevent business losses from sudden outages. So here we talk about the services the cloud provides. In rural India, using the cloud allows information technology to be infused into the smallest hamlet of India and makes access to information available to the poorest of the poor to give them a better life. By empowering them with knowledge derived through the laptop or mobile phones connected to the cloud makes the following services affordable and accessible at a low cost. Banks, e-learning, telemedicine, commodity slash stock exchanges, KYC and credit bureaus, Indian agricultural information, citizen interface portals. India will benefit by taking the cloud to rural India because the cloud has a potential to drive down costs of e-governance, education, medical care, and other government computerization initiatives. The cloud bridges the great divide between rich urban India and poor rural India and gives the same level playing field to all Indians. In some, cloud computing can help with real-time computation, data access, and storage to users without having to know or worry about the physical location and configuration of the system that delivers the services. Crop related information can capture information related to all crops grown in the recent past and thus can help farmers make decisions on what to grow next. Weather information. The cloud can store region specific weather information and as well as the weather forecast for specific durations. Again, these help farmers make crop related decisions. Crop, crop related decision making depends largely on soil information too. Apart from soil profile, it can also provide a trend of soil in the past which will help in predicting the trend in future. For example, is the soil turning acidic or alkaline, or what other changes in nature and composition of soil can be seen. Monitoring the growth. The growth of various crops can be monitored in different regions and at regular intervals. This enables growth patterns to be compared with past growth patterns. Farmers data. Region-wise farmer data can be captured, monitor and study the involvement of local farmers. This can help in the identification of core agricultural areas which are helpful for policy makers while farming framing their strategies. Expert consultation. Their solutions are available for commonplace problems the farmers frequently face. Alongside experts provide solutions to specific problems too, with a rather short response time. Although cloud computing is picking up the global market covering almost all the prime sectors, there is nothing much done in the agriculture sector. Few countries like China, Japan, some parts of Africa, USA, etc. Countries that are adopted cloud computing in agriculture. Even though the uptake of cloud computing took a while to spread, the leader as one can expect is the technology giant Japan, followed by China and the USA. Interestingly, parts of East Africa too have managed to tap into it. Through the practice is still in a nascent stage. Looking at Asia, Japan of course comes first. Korea stands at the 8th position, Singapore at the 10th, and Malaysia at the 13th. And India takes the 19th position. Surprisingly, Bhutan, which is a relatively new country in ICT, realized the importance of ICT quickly and is adopting it in all sectors, including agriculture. Benefits of cloud computing and agriculture. Data readiness anytime and anywhere, local and global communication, improve economic condition of the nation, enhance the GDP of the nation, ensure food security level, motivations of farmers and research, reduction of technical issue, rural urban movement, data availability at any time and at any location without any delay, improve in market price of food, seeds and other products. Here we have a diagram where of the agricultural system, where how the cloud helps in the development of agricultural system and the cloud-based services. So finally coming to the conclusion, the cloud computing is a game-changing phase of IT that is not only impacting the way computing services are and will be delivered, but also the way in which the users will use IT. An effective implementation of this model will encourage agricultural sectors also, which will lead to optimal benefit of shifting towards cloud. This will definitely have a positive impact in the overall economic development of the nation. Therefore, it needs a mass awareness and promotion among the prime stakeholders to acquire the full potential of it and have a well-established information base for the nation. This will in return lead to a well-connected world. This prominent technique may deliver the agricultural based knowledge along with management of natural resources and knowledge directly to the consumers, not only in a small region like a non-stop marketing or shops, but also in wider region. This will change the whole supply chain, which is mainly in the hand of large companies now, but can change to a more direct, shorter chain between producers and consumers. Cloud computing technology applicable for the improvement of agricultural growth, food grain product, economic condition, ensure food safety, GDP of the nation, and circulate information related to the agriculture. Cloud computing is a newly introduced concept, and most of the developing nations are not to acquire it and have a well established information base for the nation. This will return to a well connected world. Cloud computing has benefit to and entire economics, but substantial challenges stands in the way. Cloud computing will support the farmers access to application services at any whenever using various terminals. They request their resources from the cloud, not from a physical entity. The applications are run in the cloud. The farmers don't need to know and worry. The specific computing in India will be more and more used by enterprise. India will definitely benefit if the proposed model is implemented effectively in the agricultural sector. An effective implementation of this model will encourage other sectors also, which will lead to optimal benefit of the shifting towards cloud. This will bridge the gap between technology, information and farmers of India. This will have positive and tremendous impact on other fields also that will lead the nation towards technological development. Therefore, promotion and awareness of cloud computing technology and its use. Implementation will bring out new zenith in economic development in India. Thank you for watching this video.